Welcome to our last unit on probability. You are probably watching this video right now if you're absent today while we're going over probability and starting our brand new unit. Here's some vocabulary for you. Go ahead and jot that down. Pause the video here, jot down the vocabulary. Probability is the measure of how likely something is to occur. You've probably seen probabilities like on TV, like there's a 50% chance of raining. That's a 50% chance that it will rain. That is a probability. To find probability, we just want right here the number of favorable outcomes over the total number of possible outcomes. So probability is usually what we want to happen. Two types of probability: experimental and theoretical. Experimental is the probability that you would find in an experiment, and we're going to do an experiment in class where you'll get to test out experimental probabilities. And then theoretical probabilities is what should happen, probability in theory. Probabilities don't always line up with theoretical probabilities. They're usually going to be more aligned with experimental because that's what's happening in real life. A complement is the set of outcomes that are not the event, so the probability of what we don't want to happen. And the probability of what we do want to happen and its complement is equal to 1. A simple event is an event with a single outcome, and a compound event is an event that has two or more simple events. Keep in mind, probability is a measure between 0 and 1. If you have a probability that's negative or greater than 1, that is not a probability. You can write probability as a fraction, a decimal, or a percent. And you're going to see all three ways in class and on the test. Now, if we want to determine the likelihood of an event happening, we can categorize it in 5 ways. Impossible, that's a 0% chance it's going to happen. Unlikely is usually a 25% chance of something happening. As likely as not is a 50% chance. That means it could happen, it could not. Likely would be about a 75%, and a certain would be 100%. Certain is always 100%. If it's not 100%, it is not certain. So let's determine, over here on the left, I've got 4 examples for us. Let's determine whether each event is impossible, unlikely, as likely as not, likely, or certain. So first I have the probability of rolling an odd number on a number cube. The probability of rolling an odd number. And this is how we write probabilities, P in parentheses something. On a number cube, and that's just like a dice. There are 3 odd numbers out of 6 total, which simplifies to 1/2, or 25%, or not 25%, 50%, or 0.5. Okay, 2, rolling a number less than 6 on a number cube. So the probability of something less than 6. Well, there are 5 numbers that are less than 6. Okay, and I can call this likely. First one would have been as likely as not because it's a 50% chance of happening. Pause here and try your turn 1. Okay, so 3, actually I'll do this in a different color. Probability of rolling a 3 or more on a number cube. Probability of, which is greater than or equal to 3. There are 4 numbers that are greater than or equal to 3 out of 6. That's 2/3. And that's probably closer to likely to happen. You're probably likely to roll a 3 or greater on a dice. And then an event that has a 95% chance of occurring, that's pretty likely. It's not certain because there's a 5% chance that it won't happen, but it is likely to occur. All right, let's move on. Let's talk about sample space. Sample space is all of the possible outcomes of an experiment happening. So let's say, for example, I want to know the sample space of 4 shirts and 2 pants. If I have 4 shirts and 2 pants, let's say, what are the total number of combinations of those shirts and pants I could wear? All right, so let's say I have a red shirt, maybe I have a blue shirt, a green shirt, and a purple shirt. Okay, and let's say my pants are jeans and shorts. So let's say I have a pair of jeans and a pair of shorts. This is a tree diagram. So we're creating branches to connect different things. So if I wore a red shirt, I could wear jeans or I could wear shorts with it. If I wear a blue shirt, I could wear jeans or I could wear shorts. Same thing with green. If I have a green shirt, maybe I'll wear jeans or shorts with that. And if I decide to wear my purple shirt, I can choose between jeans and shorts. So now I can go through and list out all my possible outcomes. So I could wear a red shirt with jeans, a red shirt with shorts, blue shirt with jeans, blue shirt with shorts, green shirt with jeans, green shirt with shorts, purple shirt with jeans, or purple shirt with shorts. So how many different outcomes do I have? Or how many different combinations do we have? We have 8. We can also calculate that by by multiplying our numbers together. 4 shirts times 2 different types of pants gives me 8 combinations. So sometimes you'll be asked to draw a tree diagram. Sometimes you'll be asked to just find the total number of outcomes. Now, what if I want to find sample space with an example 2? If I have a bag that has a red tile, a blue tile, and a green tile, and then I want to pick from a second bag that has a red tile and a blue tile, what are the different combinations I can make? Well, the easy one is just do the calculation first. And we have 3 different options in the first bag, red, blue, or green, times our second bag, which has 2 different options, red and blue. So that means there are 6 total outcomes. So when we create our tree diagram, there should be 6 total outcomes. So in bag 1, I can pick a red tile, a blue tile, or a green tile. In bag 2, I can pick a red or a blue. Usually the second set of branches are going to be the same all the way through. There's our tree diagram. We can see we can do red, 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 blue, blue then red, blue then blue, green then red, or green then blue. Those are 6 different outcomes. Pause, and I'd like you to try your turn 2. I'd like you to do both of those examples. Okay. So let's look at your turn 2. One bag has a white marble and a black marble. A second bag has a blue marble and a red marble. We're going to find the sample space by drawing a tree diagram and creating a calculation. Let's do the calculation first. In our first bag, there are 2 different options, white or black. In our second bag, there are 2 options, blue or red, which means you should have 4 different outcomes in your tree diagram. Your tree diagram probably looks like this. In the first bag, we could pick a white or a black marble, and then we can pick either a blue or a red. As you can see, we can do white, blue, white, red, black, blue, black, red. 4 outcomes. Second one, John is flipping 3 coins. Find the sample space by drawing a tree diagram and a calculation. Let's do the calculation first. Think about flipping a coin. There are only 2 options, heads or tails. So we flip 1 coin, there are 2 outcomes. We flip a coin a second time, there are 2 outcomes, heads or tails. We flip the third coin. There are 2 outcomes, heads or tails, which means there's going to be 8 total outcomes in your tree diagram. So we can either land on heads or tails. Our second coin is going to land on heads or tails. And remember, we're doing 3 coins here, which means our third coin is going to land on heads or tails. So we can list all of our outcomes here. We could get all heads. We could do heads, heads, tails, and I'm just following heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, head. And tails, tails, tails. Those are all the different outcomes that we could get if we flipped a coin 3 times. So now we're going to find theoretical probability. Again, the probability that something should happen, not that it always will happen. A card is drawn from a standard deck of 52 cards. What is the probability that it is a diamond? If you don't know anything about cards, know that there are 4 of each suit in a deck: diamonds, spades, hearts, and clubs. And they all have an equal amount. So there's always 13 of each suit. So for A, there are 13 diamonds in a deck of cards out of 52. So the probability, if we simplify this, is 1/4. The probability of drawing a diamond, a card that has a diamond on it, is 1/4. B, a school contains 20 male teachers and 18 female teachers. What is the probability that a male teacher will be called by the school principal? So we have 20 male teachers, and we have to think about what our total options are. 20 plus 18, 20 male teachers plus 18 female teachers is 38, which simplifies to 10/19. So there's a 10 out of 19 chance, almost half, chance that a male teacher will be called by the principal. Let's pause, and you try your turn 3. Okay, I'll do this in a different color. A letter is chosen at random from the word marriage. What is the probability that this letter is a consonant? Remember, consonants are not vowels. So first, let's figure out our total number of events here. 1, 2, 3, 4, 5, 6, 7. There are 8 letters in the word marriage. And there are 1, 2, 3, 4 consonants. And that simplifies to 1/2. So there's a 50% chance that a random letter chosen from that word will be a consonant. And a dice is rolled. What is the probability of getting an odd number? So we know that there are 3 odd numbers out of 6 options. That's another probability of 1/2. Now remember, not all the time will you roll a dice and get an odd number 50% of the time. You could roll a dice 10 times, and theoretically, how many times would you get an odd? 5 times. But that doesn't always happen. That would be experimental probability, which we'll get to soon enough. Last thing I want to talk about is using a complement of an event, the probability of something not happening. So we have 2 red jacks in a standard deck of 52 cards. What is the probability of not getting a red jack if you select one card at random? Well, if there are 2 red jacks, think about what's not a red jack. It's all the other cards. So you have a 50 out of 52 chance of selecting a card that is not a red jack. If we simplify that, that's 25 out of 26. It's pretty likely to occur that you're not going to get a red jack. Pause and try the last 2 examples. Okay. A jar contains 8 marbles marked with a number 1 through 8. You pick a marble at random. What is the probability of not picking the marble marked with the number 5? So think about all the marbles that don't have the number 5. If you have 8 marbles, each one has a number 1 through 8. One of them doesn't. One of them has a 5. So that means 7 don't. So there's a 7/8 chance that you will not pick a 5. Pretty likely. And then finally, you have a spinner that has 5 equal sections that are red, blue, green, yellow, and purple. What is the probability of not landing on yellow? We have 1, 2, 3, 4, 5 different options here. 4 of them are not yellow. So 4 out of 5. That tells us the probability that we are not going to land on a yellow. If you have any questions on this, please ask me in class. Have a great night.